Good morning, good afternoon, everyone. I joined Influx about 5 years ago. Been in product management first 4 years. Worked with InfluxDB. For those of you who don't know InfluxDB, we are the makers of InfluxDB. InfluxDB is a pretty popular open source time series data platform, and we've been around since 2013, 2014. And I'll walk through some of the basics, what's time series, why do you need InfluxDB, and how it would fit in with your AI applications and LLM generation applications. You can think about InfluxDB as the underlying backbone, underlying backplane if you're dealing with a lot of time series data. So let's get started. First is, for those of you who don't know, just wanted to set the context here. What is time series data? You can think about time series data as a stream of data that primarily has timestamp as a primary key, right? So things like, if you want to think about use cases, things like where data generated from either your machines, VMs, services, cloud, any of the monitoring data. Increasingly also, as we digitalize a lot of our physical assets, things like IoT, you might want to measure your pulse or things like that using your healthcare device, or maybe you want to measure temperature, pressure, and things like that. So all of those basically are timestamp data, time series data. One of the unique characteristics of these time series data is they are generated in large volumes. If you're generating every 20 seconds and you're trying to store them, it could, from millions of devices, you are looking at essentially billions of data points per second. So they require high throughput. The other characteristic of time series data, as we use them in a lot of the latest mobile applications or web applications and things like that, there are real-time nature. Like you might want to act in real time. If some of the events happen, you want to capture that events in real time, and then you want to actually take action upon them. And there could also be a lot of queries concurrently running, millions of queries concurrently running together. So here we are prioritizing basically write availability, read availability, rather than consistency. Consistency may not be that important, or maybe eventual consistency is important. But then you are actually looking for, hey, I want to support a large number of writes and a large number of reads. The other thing about time series data is the nature of, hey, as the data is fresh, you may want to act upon it immediately. As it lingers on, if it's 15 minutes ago or maybe an hour ago, maybe they are used for machine learning models and so on. But then anything that's beyond a day old, week old, and things like that, you want to store it somewhere. You still want to do seasonality or trend analysis, but they may not be useful for your real-time nature. The other thing, InfluxDB, again, I just want to spend a little bit of time on the history and then spend a majority of time on 3.0. The thing is, InfluxDB, we started around 2013, 2014. One of the first things we did with 1.x was, that was around that time series was still a niche, right? So we said, hey, we want to really build a system, a platform that can support at scale all of these time series metrics and events. So we built the line protocols. You have to ingest it. The way we do it is, hey, you lay it down, you kind of put that in a line protocol, you say measurement tags and then all the fields together, and we take that and we really, really push directly to the disk. So that makes things faster. We don't have to process anything. We just take them and then parse apart the CDs and then push them directly into the disk, making it really fast. But one of the things that we did was, hey, these can support metrics and events at scale, but anything beyond metrics, after that, things like tracing or other use cases, we call that cardinality. In a time series, basically, you look at tags and the values in the tags. If there are too many of them, you're now not able to index them properly, or maybe once the index grows more and more, your data access patterns become slower and slower, so your ingestion could fall apart and so on. The next 2.x, we improved a little bit on the cardinality, but mainly we focused on how do we scale. We basically put in InfluxDB on a Kubernetes platform. We could scale infinitely and so on. We also had a new expressive processing language called Flux, which can allow you to do things in real time, write your own alerts, and so on and so forth. But what then we noticed was, one of the patterns we noticed was customers would tell us, hey, we still have a cardinality problem. We still can't as our data is exploding, we still can't manage traces, log analytics, and things like that. So we had to build this 3.0 as a real-time columnar data science platform, especially as the analytics was coming across. So there are two different patterns other than cardinality. We also saw that customers, they were still using time series, but then their requirements are becoming like, hey, for example, I can give you an example. Tesla Powerwall is has been using InfluxDB for a long time. Powerwall, for those of you who don't know, they actually battery management. You have solar panels, you can store your power in battery panels and so on. And they use InfluxDB in the backend, but they also have a mobile application that shows you how much power was generated, how much was stored, what's the consumption patterns and so on. Increasingly, they want, hey, I need my queries to come back really, really fast, within 300 milliseconds and so on. So that's number one of the patterns, right? So real-time nature of things. And then the second pattern that we saw was increasingly these data was also one of the data that has to intermingle, or you want to put it in a data lake, and then you want to analyze with other data sources, other data that you have, and so on. When you look at that, you essentially are trying to take a very voluminous kind of time series, which is a very different characters, trying to put them in a data lake and trying to operate them with different other tools and machine learning languages and so on. That's where it falls apart, and we kind of wanted to address that as well. I want to use an analogy of a fast kind of four-wheeler or car in this case, what's under the hood. We essentially built InfluxDB 3 from the bottoms up. We said, hey, because people are trying to use this and other tools for machine learning and other things, we're really looking for open source, open formats in trying to build this next generation database engine that we built. We first focused on, hey, the language that we built. We use Rust for that. Rust has memory safety, it has performance, and other thing that we did was we call this AppDAP stack, Aero, Flight. All of these are open source projects. They're very, very active. We are contributing. We are also using it within our product. So if you want to imagine, you want to build a really fast car, one of the things you ought to do is, okay, you want to build a really good engine, and that's the data fusion, right? But you also want to distribute the power to all of your power and things like that, to all of your tires and wheels and so on. And that power distribution, you don't want to lose that. You want to distribute the torque and so on. That's Aeroflight. I'm going to talk about Aeroflight and how we do that. And then the other thing is Apache Aero. This talks about, okay, how do we extract the maximum out of your data and as you try to build your analytics, intermingle them, how do we use them and not waste time in serialization and deserialization? You will see some of those things in Apache Aero. And then Parquet, last but not least, is Parquet. Parquet gives us the ability to the actual, hey, lightweight materials and things like that, if you were to use a car analogy, and make it really, really fast in a performance way and so on. So let's look at Apache Aero Flight, for example. It is an RPC framework, but as I said, think about when you're building a columnar analytics database, underlying engine is really fast. But if your data transport layer is slow, where you're still sending rows and trying to read rows and trying to convert them into rows into columns, you're still wasting time in that. So we wanted to not do that, and we have been active with Apache Aeroflight. Again, Aeroflight is a framework that has that overcomes all of the restrictions and limitations that usually the ODBC and JDBC drives of the past have. You can transfer gigabytes of data in flight back and forth. Really, really good for distributed computing and analytics. We also have a SQL interface. They implemented the SQL interface so that it's easier to build. You can write your own SQL, and it'll still use the Apache Aeroflight, the backend, to really do the distribution of data back and forth. The other thing about data fusion, you can think about the engine, right? This engine is really, really fast. We use we made a lot of improvements into this engine. This was already there, but from a time series perspective, we actually added a lot of contribution to this engine. It's very extensible query engine. It uses Apache Aero, so I'll talk about Aero in a bit. But basically, it can do streaming data analytics. Data comes in, you can do analytics on that streaming data in a columnar format. And it can also work with some of these object stores, which is S3, Azure Blob Storage, Google Cloud, and so on. Those are some of the advantages. This also is multi-threaded, it's vectorized, so there are a lot of optimizations in terms of you're looking for, hey, I want this data. It can figure out, oh, where is the data? In this partition, oh, I don't have to read through all the partitions. I want to just read through the initial metadata and get that in. This is very, very optimized in terms of speeding up performance. Apache Arrow is, again, an open source, open format that defines in-memory columnar data. It's useful for, if you're building distributed systems and you use Apache Arrow, it's very useful for interchanging the data back and forth. You have an ingester, you have a querier, which are, again, both using Apache Arrow. One of the things it does is it doesn't do serialization, deserialization, which is, basically when you send things over the network protocol, you have to serialize them, and then on the other hand, you deserialize them and so on. All of that is not required. You can see some of the examples here. Apache Arrow memory already puts it in columnar store rather than in a row format, makes it easier to send it back and forth without doing that serialization, deserialization. Very efficient for running large workloads on modern GPU and CPU architectures. Last but not least, we are also using Apache Parquet. This is a very open format, understood by a lot of industry leaders out there. You want to use Amazon Athena, Hive, Spark, all of these understand Parquet. They are supporting it. We also provide maximum data compression with Parquet. It's an open columnar format. Data is still columnar, so aiding in that analytics. But it also is it really provides a high compression, so you have minimum disk footprint, and combined with this fact that we can store it in S3 and all of the other object stores is really, really one of the things that attracted us towards using Apache Parquet. So what happens when you put all of these together? In InfluxDB 3, we now have removed the restrictions of cardinality because of the way data fusion operates. We don't believe we're using memory indexing and all of those things. We still use indexes, but they're more optimized. We have in our production systems billions and billions of series that we are able to use in a very optimized fashion, such that we are saying, hey, we don't have cardinality restrictions anymore. You can use the data stored for metrics, events, tracing, any kind of, as long as it's time series, you can use it to store it, and you can really run your analytics. It's also in real time. It's hot data in memory. So previously, in previous versions, data used to come in. We used to persist the data to store it and then make it available to read. In this one, it's not the case. Data comes in. It's already loaded in the ingester memory and available to be queried in milliseconds. So we are calling this really fast for real time, or the nearest edge of data, leading edge of data. The other thing, again, Parquet allows us to store it in a store, which reduces you no longer have to think about, oh, do I store it for just 15 minutes for now, or maybe a day? You can store it forever, but in the lowest cost object store. And Data Fusion allows us to combine the data. You can run a query. It knows how much data is in memory. It knows how much data is in S3. It can combine it together. This is an example of Terega is one of the largest gas distributions in France. They used to use legacy data historians, but they also had a kind of objective to improve their onboarding. Their onboarding of new customers would take months and sometimes quarters and sometimes even a year to onboard new customers. Because again, data historian, for those of you who don't know, they are very good in terms of preventive maintenance or predictive maintenance and so on. But it could really, they are very legacy products. If you want to onboard new customers, you got to put another big investment in trying to put in servers and all those things, and then install historian, and then do all of these things. They were not very cloud friendly and so on. So they did an extensive evaluation of InfluxDB, and they chose InfluxDB because we are really fast. We can scale very well. We separated out that compute and storage. So they're really seeing a lot of storage. So they are storing like more than 10x that they used to store with the other data historians. They're also able to reduce their TCO. Sorry, I used a timer. So TCO, they were able to reduce that TCO by 50%. So this is one big advantage. The other thing is this is one of the gaming leaders. They're one of the top gaming leaders. Every 70% of the top 1,000 mobile gaming applications uses gaming leader. But they use InfluxDB as well. Again, they were using InfluxDB. They kind of looked at other solutions because they wanted to go for high cardinality data to support millions of players and so on. But when they talked to us, they said, hey, why don't you do an evaluation on InfluxDB 3? We can not only ingest 1 terabyte a day, but they also use it because, hey, they were looking for less than 300 milliseconds for high cardinality data. Now they're getting 50x better query performance and really reduced storage costs. Okay, now let's turn back to AWS. So we did launch serverless earlier this year on AWS. It's available on Marketplace. It's a shared infrastructure, so it's a multi-tenant service. You can pay as you go pricing, no upfront provisioning, no upfront cost. You can just simply use the API if you want to use it. Now, recently, in the past month or so, we launched Cloud Dedicated on AWS. And one of the beauty, this is it's single tenant. It just focuses on your dedicated infrastructure, really gives you the advantages of, hey, if I have a large workload, I can just focus on this. It also offers enterprise-grade security. You can connect to your AWS private link and have secure access to that, capacity-based pricing. You can allow your data to be read with all of the other AWS services and so on. How to get started, you can use Marketplace to sign up for serverless, but if you want, hey, your workload, you can also talk to us and then we'll instantiate a cluster for you and we can use private offer to sign up for Cloud Dedicated. That is it. That's my content. Thank you for being patient with me.